Hello everybody and welcome back. So for today's lesson we're going to jump into the basics of expressions. And the easiest way to get started is just using a built-in method in Houdini. So I'm sure a lot of you will have done this if you've used Houdini for even just a little while, but we're just going to cover the basics. So if you right click on any channel and copy that parameter, and then on any other channel that you want to reference this value in here, you can right click and say paste relative references. So what this has done is has essentially linked these two channels, okay? And it has created an expression that is a reference to this channel. If I hover over the parameter name, you'll see here that so translate is actually the label of this parameter, but the channel names are TX, TY, and TZ. Okay, so we can now type that manually if we wanted to reference scale. So you'll see here the label is uniform scale, but the actual parameter name is scale. And expressions, we always reference the name. The label is just the human readable label for us, looking at the parameter sheet, but it has nothing to do with the expressions. So if we wanted to create a link to this, we could type CH, and then in quotes, we reference the name of this. So scale. And then this will reference this number. So then as this changes, so does this one. Okay. Now there is another method. So we copy this parameter, and then when we paste, instead of pasting relative references, we go under paste other and click paste absolute references. Now this will do exactly the same thing. Whatever this value is, this will have the same value. But this is a full path to this this channel. Okay, so from OBJ level, if it exists in OBJ level, it'll have that, then the name of the object that it's on, and then the name of the channel. Okay, whereas this is a relative reference. It basically says because I'm on the same object, I just need to reference the name of the channel. Now if we did a relative reference and went one level down, so we go inside this geo node and to the actual box SOP, and then right click and paste relative reference, you'll see that this is a little bit different. It's referencing a channel that is not on this object. It's, the channel that we're referencing is on the geo node, not on the box node. So it has to go up one level in order to find that channel. So it uses .. which says go up one. Okay. If it was inside another subnet, then and the channel we wanted to reference was on the subnet, we would say .. /TX. Okay. Now, if we paste an absolute reference here, you'll see that this text is exactly the same as what appears here, because it's not relative to where this channel is. It's just a full path from the top level downwards to the channel that we're referencing. Now, 9 times out of 10, you're going to want to use a relative reference. Okay. Absolute references can cause problems if you copy this into another scene but into a subnet, so then the path is different. If you copy it into another scene where there's already a box 1, so Houdini will automatically rename it to box 2. Any of those things are going to cause problems if you have an absolute path. There are rare occasions though where you do need an absolute path, so it's good to know how to type it or to paste it this way. But most of the time you're going to want to use a relative reference. Now we're going to use this here as an example of how expressions are built up. Okay, so the this first section is the expression name, or which is going to call the function. Okay. And then in brackets, so when you see brackets, you'll know that it is an expression. Inside will be a list of arguments that expression needs. Okay, similar to how some nodes in Houdini, they perform a certain function, but some of them require information to come in. So not this box node, but other nodes like a attribute create, you'll see it says it requires an input. So this is going to perform a function, but it needs some data. Well, that's exactly what it's like with expressions. This is going to perform a function, but it says I need at least one piece of data. Now, I'm just going to pop open the help file here so you can see this is the help file for the ch expression, okay? And it shows you here, like it's got a whole write-up explaining how to use it, and how to use a relative reference and exactly what it wants, and alternate types as well, okay? So it's always good if you're learning a new expression to open up the help card and actually see what it can do, because there's a lot more information in these. So we'll see here that all it wants is a single argument. Okay, so a single piece of information in order to perform its function, and what it wants is a path in the format of a string. So that's what this means when it shows quotes, is that it wants it as a string. Okay, for those of you who don't know, string is just is text. Okay, so if you just give it a number, you say ch1, that's not going to do anything. It has no idea what I'm asking for. Okay, so there we've given it the one function, and that's why this works. But other expressions need multiple arguments. In this case, there's a chf function which grabs that channel reference, but on a particular frame number. Okay, so let's say we've animated this channel. Okay, so I'm gonna alt left click to make a keyframe and move it forward a bit. Alt click again to make another keyframe, and we'll even alter the curve here a little. So we've got some animation on this channel, right? Now, if we want to copy that channel and reference it in X here, so relative reference, says size Z, so it's referencing this, then it's going to have the exact same number on every frame. Okay, so this is now the same. But what if we wanted to be referencing maybe one frame ahead? So if we change it to chf and just stop there, it's going to error out because it needs more information. Okay, this list of arguments has not been fulfilled, right? So we need to give it a frame number, and you'll see that this is not in quotes, which means that frame number is just the keyword argument for what it's asking for. Okay, what we need to give it is an actual number. So let's say I typed in 10. Okay, it's going to give me this value, and no matter where I go, this number is changing because this is animated, but this will remain static because it is just finding frame 10. And in fact, if I go to exactly frame 10, you see that they will have the same number because this is referencing this channel, but time shifting to frame 10 and then setting this value. Now we can do some basic maths in here, so we could say $f plus 10. Okay, so then that's going to be whatever the current frame is plus 10 frames. Okay, so this will essentially be looking at this but 10 frames ahead, right? So then as we're on frame 6, this is what its value is, and then when we move 10 frames ahead, so to 16, then this should be equal to that. See, so that's now that same value that this was, but this is now ahead another 10 frames, and so on. Right, so this is kind of how we're going to play with expressions, and over time we're going to learn more than just ch, chf, and you build up a vocabulary of expressions. But just to understand that this is how we're going to work in Vex and in HScript, and even when you do Python, it's all the same. There's an expression and then a bunch of arguments. Okay. Now, just to show a few quick shortcuts that I've been using. If you, once you've created a channel, if you want to actually flip backwards and forwards between the expression and then its evaluated value on that frame, you just left click on the parameter. Okay. With strings though, this will not work. So if we have a string parameter here, something like material, and we want to reference categories. So I can also do the same, copy and paste relative reference, but you'll see that it has created a different expression. First of all, it's used backticks, which in a string, you need backticks to say that you're using an expression. Because what if this was exactly the name of the material that we wanted to reference? Okay, then how does it know the difference between the name of the material versus if we're wanting to feed it an expression, and it must evaluate the expression and then use that to find the material we're pointing at? So a backtick is exactly how we do that. Okay. So here it's created a different expression, so CHSOP. Okay, so this is just referencing a channel string operator. Okay, which is this, and it'll do that automatically because it knows that this is a string and this is a string. If you fed it maybe a number from here, so then we say paste relative reference, then it's going to do the same thing because this is a string. Okay, if we went the other way around and copied from here and pasted into here, it's just going to be a CH reference, although this won't really know what to do because we're feeding it a string. So in strings, if we want to see the result, if left clicking is not gonna do anything. You have to middle click on the node, on the parameter, and it'll have this kind of dotted outline, and then it shows you the result. So again, if we actually put in a proper string, so it has a value that actually makes sense, you'll see that this is empty because this is empty. And then as we type something in here, then this will have something. Okay, so it's middle clicking over here, left clicking on these float and integer parameters to evaluate. Okay. Also, you want to clear a channel. See, if we go and just empty this, it's not gonna empty. Okay. We have to right click and delete channels. Okay. Or as you can see, it's Control Shift and left mouse button. So you Control Shift and left mouse click, and it will clear the channel. So that'll clear. You see, we cleared our keyframes and our expressions. And it's good to note that technically expressions in a parameter count as keyframes. So even though when you do have an expression, so let's put one in. If we shift click on it so that it takes us to the graph editor, we won't see anything in here. So the keyframes don't live on particular frames, but it still counts as a keyframe, and later there are certain expressions you can use to copy keyframes, and if you want to copy expressions, you have to actually copy them as keyframes. So the similar shortcuts work between keyframes and expressions as well. So if we have animation on here and we've got an expression here, right clicking and deleting channels is going to do the same thing. Okay. Also, if we want to reset these values back to default, we can right click and say revert to defaults, or control middle mouse button. Okay, and then that will reset those actual values back to default. Okay. Right. Now that we know a little bit of that, let's just talk about some basic things you can do with expressions. Because besides an actual reference, we can do a little bit more. So you can use your basic maths. So for example, we want to take this channel. So this is a reference to TX. So as this value changes, this value is exactly the same. But we can just say +5. Okay. And then this will be exactly that, +5, always. No matter what we set this to, if we set this to 5, this will be 10. Okay. So you can use normal maths, plus, minus, divide, which is your slash, and multiply, which is star. Okay, so if it's 5 times 5 or 2 times 5 is 10, right? So if we have this and then we, let's say, want to divide the whole thing by 2, now you'll see here you'll get a kind of a different result, because it's doing 5 divided by 2 and adding that to the TX, because it's going to perform this operation first. If we want to force a different operation, it's the same as with your like basic maths at school. You can just encompass this in brackets, so then it will calculate this whole thing first and then divide by 2. Okay, so like that. So we get a different result depending on where we put our brackets. So just be aware of that. And you can also reference other channels. So so we've got this expression here. If I right click, copy this one, and just right click and paste relative references, it's going to override the entire expression that we had. Okay, and that's not what we want. But if you click inside, so your cursor is actually visible, and say, let's say we want to, after all of this, we want to divide by this channel. Okay, well, actually, let's not divide by 0. So let's subtract that channel. Okay, when you can see your cursor, if you right click and say paste relative references, then it will actually just insert that into your current expression. Okay, so there we have that. And as we increase this value, we're subtracting from this. Okay. Then something else you can do is your basic comparisons. So if we say that, let's reference this channel in here, but we say, is tx greater than 1, right? So right now it'll return a 1, and as soon as we set this value to below 1, this will change to a 0. Now, I'm sure you must know this, but in case you don't, in coding, 0 is false, 1 is positive. So this is going to return, it's not going to tell us how much less than 1 it is or how much greater than 1 it is. It's just going to say, yes, it is greater than 1, or no, it is not. And it's going to return a 0 or a 1. So you'll see that as we change over, this flips to a 1. And that's all. Okay. Now, your basic comparisons, you've got greater than, less than. You've also got greater than equals or less than equals, right? So less than equals, in other words, is it equal to or less than? Both will be true. Okay. Now, if we want to ask, is it exactly equal? If we put a single equal sign, this is not going to work. Okay, it's going to error out. Because in Houdini, and as in most coding, a single equals is about setting a value. So you're trying to set this channel to be equal to 1, but you can't do it this way. So this is going to error out. You have to use the double equals. So equals equals is asking a question. It's saying, is this one equal to 1? Okay, and in this case, it's not, but as soon as we set this to 1, then this will be 1. And then if we go just above it, it'll go back to 0, because it's only equal to 1 when this is exactly equal to 1. All right. We can also use the exclamation mark. So this is not equals, right? So it'll be true when it's not equal to 1. So right now it is 1, it's false. But if we go anything above, it'll be 1, and if it goes less, it'll be 1, right? So these are all your basic comparisons, okay? Then also you can run multiple comparisons in one channel. So here we can go, okay, if this is greater than 1, and so in order to do and, we use the ampersand sign, but 2 of them. So and, right? Basically says this statement and whatever follows must both be true in order to return a true value. So let's create a channel reference to maybe TZ instead, right? So we're going to reference this channel, and we're going to say if TZ is less than 10. Okay, so it's asking this one must be greater than 1, and this one must be less than 10. In this case, both are true, therefore this will return a 1. But even though this is still correct, if we took this to 12, then this will go back to 0, because it's saying, yes, this first part is true, but the second part is not true, therefore it's going to return false. Okay. Then you also have or. So instead of the and, you just do the vertical bar. I never remember what these are called. But anyway, the double vertical bar, it's next to your slash key normally, or at least it is on my keyboard. So if you hold shift and hit slash, then it will give you these or. Okay. And when you say or, it basically means if either one of these two statements is true, then it will return a true value. So it doesn't matter if one is false and one is true, it will still say true. Okay, so this is true, this is false, so therefore it's returning. And only if both of them are false will this come up as false as well. Right, so that's just some basic things we can do with expressions or to combine multiple expressions, right? And you can do this not only outside the expression, but actually inside. In your arguments, you can do it as well, right? So let's say we want to go in here and we want to reference this channel, but instead of having this ... tx, we want to go, you can actually split this. So the first string we feed it is ... and then we can say plus tx, and this will still work. Okay. Now, you wouldn't really want to do this because that doesn't make sense, but often what you'll do is replace tx here with an expression like $ch, okay, for the channel name, right? So then that's referencing its own channel name, which is size x, but it's looking up one level for something called size x, okay? Which in this case, it's not going to actually find one, but I mean, we could do that on a transform node because transform also has, there we go, tx. Okay, so if we took this same expression and put it in here, then this will reference up one level for its own channel name, okay, which is tx. If we put this exact same expression in here, it'll reference an entirely different number because it's looking at its own channel name but up one level. Right, and this is the power of proceduralism. This is where, you know, it's relative to itself and relative to its own location. So this is where you can then plug this into any system and it will work. Okay. Now, you see, I'm using a couple of these dollar variables. So let's talk about these for a minute. So there's a few, like besides expressions, there's a few of these variables built into Houdini. So you get global variables and environment variables, local variables, and then you can even have custom variables. So you can create your own local or global or environment variables. So there's a few that are really common, so that you probably already have come across them, like $F for frame number. Okay. Now, while we're talking about frame number, let me just show you. If I change my playback over here to not include integer frame values, okay, then when I slide my timeline, I can slide to a float number. Okay, so I'm on frame 19.2735. Okay, but $F will still just return 19. Okay, it's going to round it to the nearest. So if I go above 0.5, then it's going to say 20. But if we go to $F, it's going to return the floating frame number. So then that'll return that exact number. Okay, that's just something very useful. Most of the time, you're going to actually want to use $FF, except for file names. Like if you're wanting to save something out, generally you're not going to want a floating frame number. Okay, so there's $F, also $T, which is the time. So that's in seconds, right? Basically, it's just a conversion from frame number. So you also have $FPS. So you could actually just multiply by $FPS, and you'd get to your frame number. Okay, so this is 24. This is based on this number. You also have $Fend, which is the end of your frame. But see if I drag my slider here, we've got 240 frames in our actual scene, but we've got 175 frames in our range. So $Fend is going to return the maximum number, the number of frames in total in the scene. But $rf end is going to grab the end of our range, okay? And we have the same thing, $f start and $rf start. So those can be very useful. Then we also have some ones that are going to return strings. So I'm going to actually type them in here. Now remember, we want to put a backtick and then say $hip. Okay, so $hip is our hip file. It's the folder where our scene is being saved. So you'll see exactly where I've saved my scene, and it's up to the folder location. Okay, but if we go $hip file, it's going to return the full path, including the actual file name. And if I do $hip name, then it returns only that name. So we can use these expressions when creating file names if we want to, let's say, append the actual scene name to our geometry name when we write it out, when we cache it. Then you can just use $hip name. But just remember to use your backticks, okay? So there's that. We've also have $os. So $os is going to return the name of the node. Okay, the name of our current node. So if I call this something else, then this will change to something else. Okay, so $os, and this can be very useful for referencing things like, let's do a quick example here. If I have a shop net and we've got just some empty materials, and if these are named correctly, so if this is material for box 1, box 2, and box 3, then in here in material we can, so we'll clear this and let's reference that material. Okay, so we got // so up one level into obj context, go inside of shopnet 1 and then look for a material called box 1. Okay, but what we're going to do is replace this section of it with $os. Now just to note, you can just type $os and it will work, okay? But I'm going to caution you guys to not do this. Like I said, you do need backticks. Sometimes it'll work without backticks. Other times it will not, okay? So you're doing yourself an injustice by getting into a bad habit of not using the backticks, okay? Because then you're going to struggle, something's not going to be working, and you're not going to know why because you're in a habit of using it without the backticks. So just put them in every time. Also, it shows you, this goes yellow to show you that it's an expression. This goes orange to show you that it is actually finding a path that exists. It'll go red if that path doesn't exist. So you're kind of getting rid of all of that if you take away the backticks. So, and if I middle click, you see there it's finding box 1. And now when we create another object and it's called box 2, it's just going to go and look for box 2 in its material. Okay. We can create box 3, and then this one will look for box 3. Okay, so there's a lot of cool, useful ways you can make use of this. Then here we've already used $ch, which is the name of your own channel. So see, if I hover over here, this is called group, and $ch is going to return group. Okay. There are also ones that are more local variables. So this is kind of relative to like attributes that have already been created, or kind of attributes that permanently exist on objects. For example, if I middle click here and I can see the center point of this box, the bounding box minimum and maximum, the size of this box, the number of points, all of this is explicit data that always exists on the object, right? So if we want to reference that, so for example, we're going to create a custom attribute, so I'll just call it foo, and then in here I say $pt. Okay, so pt is the point number. If I go under my geometry spreadsheet, you're going to see 0 to 7. So point number 1 has a foo value of 1, point number 4 has a foo value of 4, and so on. Okay, so this will not work in other contexts. So we can't go in here and type $pt. This will not work because uniform scale is a single value over the entire object, but this is a per point value. So it'll only work in any cases where the parameter is asking for a per point value. So when it's setting a value on like point attributes, it can take a per point value. It cannot do that when it wants a single value here. Okay, it just wants to know the scale of the entire object. Okay, not per point. Right. So you've got $PT. There's also $VTX, which is the vertex number, but this will not work unless you actually change to vertex. So if you've got a vertices, you see it'll work here. Okay, but if you go back to point, it doesn't work. Same as, so when you go to $PR, okay, we need to change that to primitive level in order for that to work correctly. Okay. Also, you have your centroid. So $CEX will be the X value of your centroid. So there's center, X, Y, and Z. So CEX, CEY, CEZ. Also your bounding box, X minimum and maximum. So it'll be BBX is your minimum, BBX2 is your maximum, BBY, and so on. So you access your bounding box values, and then also size X and size Y and size Z, right? So this is how we access these sort of local variables that are per point or per primitive. And while we're talking about this and using an attribute create, I just want to point something out about sort of an old method. Now you shouldn't really learn this old method, but if you come across it, you just need to know what's happening. You'll see that so there's a section here called local variable, right? Now, if we've created a custom attribute, given it a value, so it's got a value of 10, and then we want to reference it somewhere later on. So I'll just use an old point node, because this is also per point. And in here we say, now the old way of referencing that value would have been to say $foo, all capitals of the same attribute name. But you'll see that doesn't work here, okay? If you switch this on, then this will work, okay? Now what this is doing is creating a variable map. So it's saying that the attribute name foo, or lowercase, can be called using the variable foo, all capitals, okay? Now how it knows to capitalize it, it's just that if this is empty, it will take this but capitalize it. If we feed this something else, then that will be the variable that it looks for. So then this will still not work, and we would have to type that, okay? So this creating of a variable map is kind of an old moded method, and the reason for that is because things have moved more towards vex style referencing, as you can see over here with an @ sign and all like the lowercase channel reference. This is vex style, okay? So this is how it should be referenced now. So if we just type @foo, that'll work, okay? Because that's the name of our attribute, and we're just using an @ to access that, okay? So you guys should use this method this way. But if you happen to open an old scene or an old tool and you see some sort of where it says $foo or dollar, whatever the attribute name is, you just know exactly what's happening. And if there's a $sign trying to reference an attribute and it's failing, even though that attribute does exist, it's because the variable map has probably been deleted somewhere along the line. So you can either change it to a vex style reference and then you don't need the variable map, or you can recreate the variable map, okay? So yeah, that's something I want you to be aware of. And then also, so global variables, right? So accessing something like $hip, okay, is a global, well, that's an environment variable. So $hip, right? But we can create our own if we want to. So under edit, aliases and variables, if we just go and create a new variable. So under here, I say, let's call it test, and I'm going to give it a value of 5. Okay. then it inserts it into this list. So there we go, test 5, okay, and I can close this. And now if I reference $test, it's going to be a value of 5. Now this is really cool, but be careful, okay? Don't go and create values like this and access it. I mean, basically, if you open this, somebody else takes the tool that you've built and opens that up in their scene, and they don't have that exact same environment variable, then this is going to error out. Mostly this is used in a studio context, where the studio actually has these scripts that run when Houdini opens, and it will set an environment variable. So you'll create like a dollar job or a dollar scene or some kind of variable, which then lets you access maybe your exact shot number and scene number based on the project you're working on. Okay, and every artist in the studio that opens their scene has that same script running, so they do have that same environment variable, and then that variable can be overwritten with scripts. So it's very powerful if used correctly, but in this exact way, like I wouldn't use it this way, going and just setting a value and then accessing it, okay? Because it's going to cause things to break. Right, so this is just a little bit of an introduction to HScript expressions. Okay, HScript, you can also write certain expressions in the actual terminal, which is what we're going to sort of discuss briefly next lesson. That's something that's used a lot less often, but this type of stuff is used all the time, right? Even when using Vex, you're still going to be creating parameters, and those parameters are going to need channel references. So we're going to dive more in the future into more expressions. We're going to build up the vocabulary of HScript expressions that we know how to use. But for now, this is just the basics. Okay, so I hope you guys enjoyed that, and I look forward to seeing you in the next lesson.